press the bell icon on the YouTube app and never miss another update.
Okay, children. Hello, everyone. In continuation with the previous session, what we have studied, all we are discussing about motionless straight line. See, in motionless straight line, about horizontal motion we have done with both uniform as well as non-uniform accelerated bodies, how we need to solve for all the problems or kind of concepts we have studied. When it comes to vertical motion, in the previous session we have started with, and in vertical motion already we have discussed about freely falling body and their applications, a few of them, and then for vertical projected body we have written the equations of motion. Means not to study the vertical motion, right? What are the equations we have written? V equals to u minus gt, s equals to ut minus half gt square, and one more equation we have written is v square equals to u square minus 2gs we have written, s nth equals to u minus g into n minus 1 by 2. They are all the equations not to study the vertical motion or vertically projected body. And somewhere we have stopped while writing the equations for motion parameters of vertically projected body. First we will discuss that for the session today. Motion parameters of vertically projected body, motion parameters of vertically projected body. So what they are? Motion parameters. So what is the meaning? I told three of them in the previous session itself what we have to study with. So like from here, if I am going to throw the body vertically up, this point we used to call it as point of projection. If I give some small velocity at the point of projection, no doubt it moves up, it reaches a maximum height. So we need to write an expression for maximum height. What are the motion parameters we are having? One is maximum height of vertically projected body, and then time of ascent. I given the definition of this in the previous session. Once again I will recall it. Time of ascent, and then time of descent. This is time of descent, and finally time of flight. So these four are the motion parameters. This is H maximum we need to find out. This is time of ascent, time of descent, time of flight. So maximum height is, how to define maximum height? It is the maximum vertical displacement of the body during ascent or during time of ascent. What is maximum vertical displacement? That is nothing but maximum height reached by it. By the time when it reaches the maximum height, this is what H maximum. It is thrown up with a velocity u. This is H maximum. This is the expression. We need to write the expression for maximum height here. Before that, what will be its velocity when it reaches the maximum height? 0. We are all aware. When it reaches the maximum height, its velocity will become 0. Or you can say the displacement of the vertically projected body where its velocity becomes 0. Displacement of a vertically projected body where its velocity will become 0. That itself we should call it as what? Maximum height. So now how to obtain the expression for maximum height? See, you know for this motion A equals to what? Minus G. Throughout the motion A equals to what? Minus G. What is the relation corresponding to U, V, A and H? H means S displacement. Or what is this one equation of motion we have written? Can you tell me? Here V square equals to, for vertical motion we are having this relation, V square equals to U square minus 2 into G into S. Yes or no? one of the equation of motion we have written for vertically projected body. What is that? V square equals to U square minus 2GS. If S equals to H maximum means what? If this displacement is H maximum, then what happens to the final velocity? Becomes 0. This is a condition we have to apply there. When S equals to H maximum, the value of V will become 0. Substitute for these two values here. What you will get? Implies 0 equals to U square minus 2 into G into, in place of S I need to write what? H maximum. Rewriting this relation, 2G into H maximum equals to U square, or the expression for H maximum will be equals to U square divided by 2G. This is the formula for what? Expression for what? Maximum height. This is the first relation which we have derived. Expression for maximum height is what? U square by 2G. What is that? U is the velocity with which a body is thrown vertically up, and if H maximum is the maximum height it has reached, relation for that is what? U square by 2G. Most important formula. Next we will see the expression for time of ascent. Second one is time of ascent. Time of ascent. How to define time of ascent? It is the time taken by vertically projected body to reach the maximum height. Time taken by vertically projected body to reach the maximum height, we used to call it as what? Time of ascent. So we need to obtain an expression for time of ascent now. How to obtain? See, if I say like by the time when it reaches the maximum height, its velocity will become how much? 0. Yes or no? You know the relation, let's say for t equals to time of ascent, means for time taken by the body to reach the maximum height, that is t equals to ta, final velocity v will become how much? 0. Then equation we are having v equals to what? U minus gt. This is one kinematic equation we have written for what? Vertically projected body. V equals to what? U minus gt. Substitute for these two conditions into this equation, what you will get? 0 equals to U minus G into time of ascent. Or I can write this one as G into time of ascent equals to what? U, or expression for time of ascent will be equals to what? U by G. This is the formula to find out what? U by G. Time of ascent formula is what? U by G. This is the expression. And next we are having time of descent. We will see what is the time of descent relation. I hope you have written this. I will rub this part. Time of descent means time taken by vertically projected body from where to where? From maximum height to reach the point of projection. You can write all the definitions also. Time taken by the vertically projected body to travel from maximum height to reach the point of projection. From maximum height to reach the point of projection, time taken is what? Time of descent. So how to write the expression for time of descent now? Time of descent, right? Time of descent. What is the displacement it travelled from here to here? Y is nothing but H maximum only, na? Y is nothing but H maximum. Then time taken to travel is what? Time of descent. You know this relation, y equals to half gt square. We are aware of this formula. Y equals to what? Half gt square. Here y equals to what? Y equals to H maximum, and H maximum formula what you have written? U square by 2g. Y equals to H maximum, and this value it will be equals to what? U square by 2g. Right? Sorry, I think 1 minute. For time of descent, if I want to write, you can imagine this one is thrown from this particular maximum height. Just like when it is coming down, you know, its initial velocity becomes 0. No? For the return journey, the value of u, it will become how much? 0. If it becomes 0, to travel this displacement, time taken is time of descent we are calling. What is the time taken formula you are having? Root of 2y by g. In the previous class we have studied. Time taken by freely falling body to reach the ground is root of 2y by g. But y is what? Maximum height. Formula is what? When it is thrown with vertical up with velocity u, H maximum formula here we have written here, y equals to H maximum, it will be equals to u square by 2g. Okay, now substitute these values into this equation. What you will get now? So for y equals to H equals to H maximum equals to u square by 2g, t will become what? Time of descent will be equals to root of 2 by g into, in place of y I need to substitute this one now, u square by 2g under root. See this 2 they will get cancelled. Remaining is what? U square by g square. U square by g square means what we will get? Time of descent equals to root of u square by g square means u by g. This is the formula to write down what? Time of descent. You just observe these two relations over there, time of descent and time of ascent. How time of ascent and time of descent are related. From these two equations you can say that time of ascent is always equals to time of descent. In case of vertically projected body, time of ascent is always equals to what? Time of descent, and it will be equals to how much? U by g. This is the formula you have to remember for what? Time of ascent as well as for what? Time of descent. So next, derive the expression for time of flight they will ask. What is that? Derive the expression for time of flight. Time of flight means directly you can write time of ascent plus time of descent is time of flight. So that is u by g plus u by g, 2u by g you will get. But few times they will ask you to derive the relation itself. Instead of from these two, they will ask you to derive. Obtain the expression for time of flight of a projectile. How to write? Time of flight. Time of flight means what? Time of flight means time taken from point of projection to reach the same point of projection again, to come back to the same point of projection. Means I thrown from this point u, just goes up, reaches the maximum height, once again comes back to the same point of projection. That itself we should call it as what? Time of flight. For t equals to time of flight, see, t equals to time of flight, comma, what is the value of y it has travelled? It is started from here, went there and came back to the same point. Then what is the vertical displacement? Not distance I am talking. Distance travelled is h max plus h max, 2h max you can say. But I am asking about displacement. Displacement starting from that point, final position also same, initial position also same. Obviously displacement is how much? Final position minus initial position equals to what? 0. So that's why for t equals to time of flight, y equals to 0. So here we are intended to find out the expression for time of flight. While writing for time of flight for vertically projected body, for t equals to time of flight, the value of displacement equals to 0, or this is vertical displacement. Vertical displacement is 0. Remember this point. Vertical displacement will become what? 0. Why? Because starting point is this, ending point is also that. You know the definition for displacement, final position minus initial position. Final position is this, initial position also the same. That's why displacement is 0. During this time what? Time of flight. So then equation for vertical displacement y equals to what? Ut minus half gt square relation you are aware. Implies 0 equals to, if I substitute for y 0, the value of t will become what? Time of flight. That means u into time of flight plus, sorry not plus, minus half into g into time of flight square. Take this to the left hand side, further simplifications here now. G into time of flight square by 2 equals to u into time of flight. One time of flight they will get cancelled. So finally if we write for it, time of flight will be equals to 2u by g. This is the final expression which you have to remember to find out time of flight of the projectile. So once again, vertical displacement is 0 during time of flight. Why? It starts from that point, once again comes back to the same point. Meanwhile, what will be the total vertical displacement it covered? 0. So time taken for that journey itself is what? Time of flight. Time taken from the point of projection to come back to the same point of projection. So is called from point of projection to come back to same point of projection in time is time of flight. So if you write for the expression for vertical displacement for kinematic equations what you are having for vertically projected body, using that relation, substituting for this condition into this equation, finally you will end up with time of flight equals to what? 2u by g, or generally you can say time of ascent plus time of descent. Time of flight is time of ascent plus time of descent. This is all right, relation among them. And always you remember time of ascent will be equals to what? Time of descent. It will be equals to how much? Time of ascent equals to time of descent will be equals to u by g. Sum of these two itself is time of flight. So this is all about vertically projected body, how you need to solve for the problems or the points related to motion parameters. This what are the motion parameters we have studied? What is the expression for maximum height? U square by 2g. Time of ascent u by g. Time of descent u by g. Time of flight 2u by g. So this is like, if you want to properly communicate in any of the language, the basic alphabets of those language we have to learn. As I know, if I want to speak it in English, speak in English without knowing ABCDs, you know, how you can talk something or write something, or without, how can you form the sentences, all those meaningless it is, foolishness without learning a proper basic alphabets. Learning certain language is meaningless or foolishness. In the same way, if I want to study about the kinematics, particularly about this vertically projected body, if I want to study, all these three equations should be of that kind. How you will remember your name? In the same way, throughout the course of this physics discussion what we are having, we need to remember for these relations for maximum height, time of ascent, time of descent, and the values related to what? Time of flight values. You have to remember for all the values. You should not miss out for, or you should not forget for these values. That's what one thing which you have to remember with regarding what? Motion parameters for vertically projected body. Now we'll see in continuation for this some more parameters I'm going to add here. We'll see that. Just check with a few more parameters like, hope you are getting all the points out there. Okay. So this is about vertical projection from the ground whenever you are going to throw a body, what all it is going to happen. Let me add a few more points for this vertical motion. Now I am having a body, somewhere a ball is there at a height of h. At what height the ball is? At a height of h. See carefully, go through these points there. A body is at a height of h. Now instead of dropping the body, if I am going to throw a body vertically downward, I am going to throw a body down, I am going to give some initial velocity for this, see, instead of dropping. Dropped means initial velocity is 0. I am not intended to mention again velocity in drop, freely falling already we have studied. This is something like a body which has been thrown down with a velocity u, and if it takes a time of t seconds to reach the ground, what is the equation corresponding to this particular motion now? See, it is just like vertical motion only. Instead of throwing up, I am going to throw it from certain height. From certain height I am going to throw it down. Throw it down means I am giving some velocity. Initial velocity we are aware, time taken you know, displacement we know. Let us say I am reaching the ground if its velocity is v. Now tell me with what acceleration it will move. A equals to plus g you have to consider. Why? It is given down the x velocity. It is made to move down. Instead of dropping, I am going to throw it down. What equations you have to write? For a body, I am going to write this, see, for a body which is thrown down with a velocity u, from height h, For a body which is thrown down with velocity u from height h, equations are, I am going to say velocity on reaching the ground and time taken, how to write all the points I am going to write. Same equations which we have studied, v equals to u plus at. So what I need to write down here now, v equals to, in place of a we need to rewrite for the value of what, g, that's all. V equals to u plus gt, that's all. Similarly, h equals to what here now, displacement travelled, h equals to ut plus half gt square, and then v square equals to u square plus 2gh, Snth equals to u plus g into n minus 1 by 2. Substituting for just value of a, only thing addition for freely falling body, we are giving some velocity also. Actually freely falling body means this u terms will not be there. Why? Initial velocity is 0 for freely falling body. It's not a freely falling body, this is a body which is thrown down with velocity u. If a body is thrown down with velocity u, you have to inject a velocity u for it. So what happens to its motion? That's how we need to study for equations corresponding to this. So what is the velocity on reaching this point means v equals to root of u square plus 2gh. What is the velocity after a time of t seconds means v equals to u plus gt. So like this you have to solve the equations for a body which is moving down with, that's what, if it is thrown down with velocity u, how to write the equations. This is what you have to remember. Hope you got the point. Now, thrown up we have seen, thrown down we have seen, dropped we have studied. Now one more important thing, vertical projection from top of the tower. What is that? Vertical projection from top of the tower. What is this concept? Vertical projection from top of the tower. Take the heading as projection from top of the tower, or vertical projection you write otherwise. This is vertical projection from top of the tower. Vertical projection from top of the tower. Vertical projection from top of the tower. What this concept is? For example, you are standing somewhere on a roof of certain height, above some 100 meters or some 10 meters above the ground you are standing. Now, I am going to throw the body vertically up. I am going to throw the body vertically up from where? From the top of the tower. If it reaches back onto the tower itself, just like vertically projected body, you have to study. That is different scenario. That is common, that which we have studied earlier in the previous studies. So, but I am standing almost at the edge of the tower. Where we are standing? Almost at the edge of the tower we are standing. See this one. Okay, na? This is the tower on which I am standing. Let me see. This is what the person is standing here. Standing here. Almost at the edge of the tower. I am not well on the middle of the tower, remember. I am almost like edge of the tower. Just if this is the tower position, right, I want to stand, I am going to hold. This, the place where I am going to hold the chalk, right, it doesn't fall over on the surface of the tower. Means he is going to throw a ball vertically up like this. What happens? No doubt it reaches the maximum height, once again comes back and it just falls where? At the foot of the tower it is going to fall. Where it is going to fall? At the foot of the tower. This is a problem related to vertical projection from top of the tower, where the ball reaches the foot of the tower after it is going to reaching the maximum height. Once if it reaches the maximum height, it makes a transition back to where? To the foot of the tower. Problems on this tower, top of the tower problems are most important. Some applications also I will explain how they are going to ask the problems and how we have to solve this particular kind of problems. We will study them one by one, we will discuss. So firstly, basically, what is the concept you have to study? So like, it is just like vertically projected body only, no doubt. It is thrown up with a velocity u, reaches the maximum height and its velocity becomes 0 there, right? Intermediately its velocity becomes 0 and once again it just comes back in the opposite direction. But this is thrown from height where it is not going to fall on the tower. I told you he is not well on the tower here. is at the edge of the tower is standing and it is thrown up into the air, so that by the time it is coming down, it will not come to the ground then. And you don't think that if it is thrown like this, it will fall. It won't fall like this now. If it is pure gravity motion, in the sense, if a ball is going to be thrown vertically up, it should come back in the same path in which it has travelled. That is for pure gravity. If I take air resistance also, if there is some wind is blowing or something, if it is thrown like this, it may fall over here like this. This is the condition when air resistance or wind resistance is going to be considered. And I told you in the beginning sessions itself, for vertical motion, unless I am going to mention about something about the air resistance or the wind resistance, right? All these bodies supposed to move only under gravity. Only under what? Gravity. So when we are going to mention about gravity, we have written time taken to reach the ground is root of 2h by g for freely falling body. We have written a small conclusion. I have not mentioned there, you will just see there, or else after this point I am going to conclude that point also, let it be. So now come back to this. A body is going to be thrown vertically up from the top of a tower of height h. This is the top of the tower of height h, so that it reaches the ground. This is a point of projection and this is the point where it reaches the ground. Let's say t be the total time of journey, means from here to go to the maximum height and once again come back to the ground. What is the total time of journey we are having? T. So let me write down in the complete sentences. Consider a body thrown up. Consider a body projected up from top of a tower, top of a tower of height h, capital letter H, with velocity u, of height h with velocity u. Let t be the time taken to reach the ground. Let t be the time taken to reach the foot of the tower. So this is the initial data what we are having related to this problem. They are supposed to ask, by giving the value of u and h, what is the value of t, they may ask, or by giving the value of u and t, they may ask you to find the value of h, how much it is. So and so kind of applications they are going to ask, and how to solve for it, how I need to find out for this particular problem, how we need to initiate this problem. Means, no doubt, a body is going to be thrown vertically up. Means vertical projection concept only how to take here. The body is thrown vertically up, means its initial velocity is how much? Initial velocity will be u. What is its acceleration when it is moving up? A equals to what? Minus g. A equals to what? Minus g. And what is its displacement? It is already at a height of h. See, initial position is h, final position is what? 0. With respect to the ground we have to take. What is the initial position of the body from where it has been thrown? From a height h, initial position. Final position is what? 0. I will write, see here, initial velocity, this terminology we are all aware, I am not going to write again what is u. U is what? Throughout our terminology, u is nothing but initial velocity of projection. U equals to u itself here. Acceleration of the motion is what? Minus g. Displacement, this is important. Displacement, comma, y. How to write? Final position minus initial position. Final position minus initial position. What is final position here? Initial position. Final minus initial, na? What is final position? 0 minus what is initial position? H. It is already at a height of h. That's why 0 minus h. This is what displacement is. Or I can write this one as what? Y equals to minus h. See the parameters which I have taken. Velocity of projection, acceleration minus g, and displacement is how much? Minus h. And what is the time it has taken to reach the ground? They are given t equals to, or time taken to reach the ground is what? T seconds they are given. Okay. So if t is the time taken to reach the ground, then Equation for motion for vertically projected body in terms of displacement and time. How to write? We have, I'll write like, see, we have, what do we have? Y equals to ut minus half gt, or ut plus half at square only, right? Displacement y equals to what? Ut plus half at square. If I rewrite this relation, what is the value of y here? Minus h equals to ut is what? Ut itself plus half into, what is the value of a? Minus g into t square. Rewriting this equation, finally we can write like h equals to minus ut plus half gt square. This is the expression for height of the tower. Important problem. This is what expression for what actually? Expression for height of the tower. Whenever I am going to recall for height of the tower means you have to remember h equals to what? Minus ut plus half gt square. We have rewritten, just multiplying this throughout the equation with a negative sign. Minus into minus plus h. This will become minus ut. Again minus into minus plus. Expression for height of the tower. Height of tower. All the problems on height of the tower means you have to make use of this equation. What is that? H equals to minus ut plus half gt square. See, once again I am going to recall. If a body is thrown vertically up from the top of a tower of height h with a velocity u, it reaches the foot of the tower in a time of t seconds, then the equation corresponding to the height of the tower is h equals to minus ut plus half gt square. That is the expression which you have to remember, not to find out what? Height of the tower. See, h, u and t, three terminologies are involved here. What are those? Height of the tower, velocity of projection from top of the tower, time taken from point of projection from top of the tower to reach the foot of the tower. Three parameters are there. If they ask you to find out any one of these parameters by giving two parameters, you have to make use of h equals to minus ut plus half gt square. You have to make use of this equation. I hope you got this, right? Relation between height of the tower, velocity from top of the tower, velocity of projection from top of the tower, and one more is what? Time taken from point of projection from top of the tower to reach the bottom of the tower or foot of the tower. So this is the expression. See, if they ask to find the value of t here, how to write? By giving u and t, what is the value of height of the tower means, directly I can find out this relation. I'm going to rub this. I hope you have all written this. Here, expression for time taken to reach the bottom of the tower is, therefore, time taken to reach the bottom of the tower. How to write the expression? Tell me now. Just small correction. This is very important relation which we are going to write. Therefore, time taken to reach the bottom of the tower. Time taken to reach the foot of the tower is, time taken to reach the foot of the tower. Foot of the tower is question mark. So we need to solve for it now. What is the equation we are having? H equals to minus ut plus half gt square. What is that? H equals to minus ut plus half gt square. I am going to rewrite this equation, see, into this form. I can rewrite this one as gt square. I am going to take the LCM as 2 and simplify this equation. What you will get? Gt square. This will become minus 2u into t minus 2h equals to 0. 2h it will become, taking into the right hand side again, to the other side, we will get what? Minus 2h into g. This equation is in the form of ax square plus bx plus c equals to 0. What does this expression represents? This is ax square plus bx plus c equals to 0. This is in this form, right? This a quadratic equation in x, we are aware. Ax square plus bx plus c equals to 0 is what? A quadratic equation in x. How to find the value of x means we have roots for the quadratic equation. What are the roots we are having? Roots of the quadratic equation, what we are having? X equals to minus b plus or minus root of b square minus 4ac by 2a. What are the roots of the quadratic equation you are having? X equals to what? Minus b plus or minus root of b square minus 4ac divided by 2a. These are the roots of the quadratic equation, right? But we know what is the value of a here. A is nothing but g, na? Here, just write for ABC values. A equals to what? G, no doubt. What is the value of b here? This minus 2u is b. B is nothing but what? Minus 2u. And the value of C is how much here? Minus 2h. C equals to minus 2h. So finally substituting for ABC value into this equation, what you will get? This x is nothing but what? T. Our equation for which we need to find out the roots are what? Roots of the equation means finally we need to find the value of t. T equals to minus of b is nothing but what? Minus 2u. Minus 2u plus or minus root of b square means 4u square. See? Minus 4 into a is nothing but what? G into c is nothing but minus 2h. This is what? Divided by 2a. 2 into a is nothing but what? G. This equation is important. How they will ask the problems on them also, I will just explain. Just go through. So finally minus into minus plus. So this is t equals to 2u plus or minus root of, see 4 I will take common from this. 4 into u square plus 2gh you will get. See 4 I have taken out, remaining is what? U square minus into minus plus 2gh it is remaining. This is whole divided by 2g. So further simplifications here now of this part. Further simplification. If I take out 4 out of root, it will become 2. Root 4 is 2, right? The 2 I will take out. So this 2, the one which will take out 4 from root, right? The 2 and this 2, all they will get cancelled. Finally, I can write the equation as t equals to u plus or minus root of u square plus 2gh divided by g. This is the expression which you have to remember to find out time it takes to reach the ground. What is the time taken by this vertically projected body from the top of the tower to reach the bottom of the tower means u plus or minus root of u square plus 2gh by g. They will ask a problem like this. A ball is thrown vertically up from the top of a tower of height 10 meters. Height of the tower is 10 meters given. From here they are going to throw the ball upward like this with a velocity of 5 meter per second. What is the velocity with which it has been thrown? 5 meter per second. So it reaches the maximum height. Once again comes back to the ground, bottom of the tower like this. It just goes there and reaches the bottom of the tower. What is the time taken to reach? Means height 10 meters they are given. Velocity of projection is 5 meters they are given. H and U they are given. U and H values. G is 9.8. Wherever the substitution you have to do, without any reference or given in the problem, they have not mentioned anything about G means you have to take by default the value of G as 9.8 meter per second square. In few problems they are going to assign the value of G as 10 meter per second. Then you consider G as 10 and you can solve the problems on them. Okay. So this is about expression for height of the tower and time taken by the vertically projected body from top of tower to reach the ground. This is the relation which you have to remember with. I hope you got all the points related to projection from top of the tower. Where and all you can make use of this application of projection from top of the tower. See this top of the tower problems, they will ask you the problems in n number of ways. A few examples I will discuss now. We will see. We will just see for examples where and all we can make use of these height of the tower problems. The concept related to the height of the tower we will study. Okay. I'm going to ask a small problem here, see. It's like, I'm having a chopper or helicopter, anything you say, right? Chopper is rising up with certain velocity, or instead of chopper, first let me take an example of a balloon. I hope you are all aware of hot air balloons. So hot air balloons means just like a person can sit inside the balloon and they can move up, right? Inside the balloon they can move up. You are having some time, you can continue with that. Hot air balloons, you might have seen, even a person will be sitting in that, they will be moving up, they will travel in the hot air balloons, they will fill some gas over there so that it will be lifted up, they can accelerate it or they can make it to move with uniform speed or so on, just like a parachute action is going to take place there in case of hot air balloons even. Okay, so in such an hot air balloon, see, I am going to consider a hot air balloon like this. Like this. This hot air balloon is rising up with a velocity of V naught, let me say, above the ground, right? It is at a height of h above the ground, let me say. Hot air balloon is at a height of h naught above the ground or h above the ground, and it is not at rest, it is moving up with a velocity of V naught above the ground. Okay. So now a person who is sitting in this hot air balloon, right, is just trying to drop a stone from this hot air balloon now. He is trying to drop a stone so that it reaches the ground. Okay, now they will give time taken by this stone. He is not throwing down or throwing up. Keep it in mind. He is just dropping the ball. He is just dropping the ball when this balloon is rising up with certain velocity above the ground at a height of h. He is just dropping. Keep this point in mind. Person inside the hot air balloon is not throwing it in any of the way, any of the direction. He is not throwing it up, or he is not projecting vertically up, or he is not throwing it down, or he is not throwing horizontally or in any other way. Inside that he is just trying to drop the ball, stone, ball or stone, whatever it may be. So whenever he is going to drop from this height, right, they are saying that time taken by it to reach the ground is t. Then height at which the ball has been dropped is, they will ask. You may think like it is the concept of like nothing, no velocity is given, that's why initial velocity is 0 and time taken is t, displacement traveled is what, this h if you take, and writing this as h equals to half gt square and t equals to root of 2h by g. If you want to write for this problem, then it will be a wrong one, is not correct. Okay, this is not the problem related to freely falling body, even though in the terminology they are going to mention very clearly that a person sitting in a hot air balloon is going to drop a ball when the hot air balloon is rising up with certain velocity by the time when it is at a height h above the ground. By the time when it is at a height h above the ground, person sitting in that is going to drop the ball. When he is going to drop the ball, it reaches the ground in a time of t seconds. Then they may ask for height or time or anything they may ask here. This problem you need to view in similarity to height of the tower problem. Just like just now we have studied the concept of what? Projection from top of the tower. In the same way you need to view this particular problem. How means? You may ask, sir, you are telling that it is dropped freely. Of course it is dropped freely. From where it is dropped? From this height, no doubt. From where means within which is this body is not at rest. Keep this in mind. If this body, if this person inside the balloon, this entire balloon, if it is at rest and if it is dropped freely, then it is a freely falling body. But the person from where he is going to drop, he is not at rest. That system is not at rest. That system is moving, rising up with certain velocity. Then even though it is dropped freely, this balloon will rise along with this this stone which has been dropped, right, will be insisted with this velocity v naught. Remember this. With what velocity balloon is rising up, same velocity will be insisted for the ball which is going to be dropped from the balloon. Then what happens? No doubt it reaches up and once again it is going to reach the ground. It is just like, see, from this height h, ball has been thrown up with a velocity of v naught, you can say. Then you can write What is the expression for height of the tower? We have written h equals to minus v naught into t plus half gt square. The same concept you have to make use even for the solving the problems related to this balloon problem. Okay. See, if a stone is dropped, if let me say a balloon is rising up, I'll write this problem, I'll tag this or I'll frame the sentence for it how to write. A balloon is rising up with a velocity v naught, stop. A person drops a stone from it and reaches the ground in t seconds then height from which the ball has been dropped is, then height of balloon when the stone is dropped is, question mark. What is the height of the tower means? This is the relation. H equals to what? Minus u naught into t plus half gt square. They are saying a balloon is rising up with velocity v naught. A person drops a stone from it and it reaches the ground in a time of t seconds. A person drops a stone. From where he is going to drop the stone? From a balloon which is rising up with a velocity v naught. From that he is going to drop it, and so that it reaches the ground in a time of t seconds. So that from what height he has thrown the ball means minus v naught into t into half gt square. In the same problem they will ask the questions. I am going to change this scenario of the same problem. See here, concept is same, different ways how they are going to ask the problem. Like a chopper is rising up with certain velocity, like somewhere in flood affected areas, they can't move on the roadways. They want to supply some food packets for the affected people over there, flood affected people if any, right? If they want to supply some food packets for them, they are going to take through the some choppers, let me say. Now the chopper is rising up with certain velocity above the ground, right? Above the ground, it is when it is at a height of h. Food packets are being dropped from the chopper. Then what is the time it has been taken for those food packets to reach the ground? Or if that food packets reaches the ground in a time of 5 seconds after they have dropped, from what height they have been dropped? Same kind of application. Chopper is rising up, just like balloon is rising up. A body is thrown up from the top of the tower. All the applications, all the problems related to this concept of height tower problems, right? Generally we used to call them in kinematics as tower problems. These tower problems you have to remember. And two more points related to this tower problems I will just mention, like after discussing two more points related to vertically projected body, how the velocity at various instances, right? Based on that I am going to give the expression for what is the velocity on reaching the ground. With what velocity it is going to reach us the ground, that is what we have to write. So that is all based on one point here, like if it is thrown up with velocity v naught, goes there, and once again when it comes to the same height, to the same height where it has been thrown, right? To the same plane of projection we can call it as. When it comes to the same plane of projection, velocity will be same as that of how much it has been thrown, but in the downward direction. So that is one key point which we have to learn. Some points related to this kinematics where you will study, like some points like we will call them as shortcuts or tricks in solving certain problems, right? Here and there we will be making use of those tricky knowledge you need to have in kinematics. So the tricks in remembering certain relations or remembering certain parameters when in case of vertical projection. So that I will discuss. Generally we used to call them as mirror relations for vertically projected body. So those things majorly while solving for competitive you need to be quick enough in solving for a problem. Instead of lengthier you need to make it as short as possible you need to make. So for that purpose, right, some shortcuts you have to remember. Shortcuts in the sense, it's not like they won't come from somewhere else. They are derived, they're all obtained from making certain equations by solving for certain equations, right? We have obtained at some end products. So they will be very useful in solving certain kind of problems or equations. If you make use of them, problem becomes very shorter instead of lengthier. So kind of relations. So those kind of things I am going to mention them for the next session. Almost we have done with this motionless straight line. Two more topics are left out, like relative velocity. Let us see whether I will mention that here itself or along with plane I am going to discuss. I will just let you know in the next session. I am going to when we are going to discuss with, we are going to have small discussion related to the either relative velocity to be mentioned here or even in plane. Once again we have to study that, whether we need to study it there. I will just have a come back to that. So almost we are done with that. Some applications we have to study as far as a competitive perspective, right? So how the problems they are going to ask in case of vertical motion. I told you, right, some tricks and tips in case of kinematics, particularly in case of straight line. If you are thorough with this straight line, the coming chapter plane will be very easier for you. Plane is combination of this both horizontal and vertical motion. I told you on the day one of my discussion, a body ant is moving along only one direction. It can move in a plane from one corner of the board to other corner of the board, that is plane. Or in space, even like housefly can move from that corner of the room somewhere in front of you. That is motion in 3 dimension. It is 2 dimensions is what? Plane. If you are thorough with all the points, that is just combination. Horizontal motion we have studied, vertical motion we have studied. So that both combination itself is what? Plane. So that we are going to study in the coming course of discussion or in coming sessions we are going to learn with. So that we'll have the discussion further. So I hope with this for today's session I am going to wind up. I hope you got the points majorly related to what all we have studied. Motion parameters of vertically projected body and some points. Time of ascent, descent, flight, maximum height relations. You have to remember maximum height is u square by 2g. Time of ascent and time of descent is u by g. Time of flight is 2u by g. So using these relations where and all it is required is so efficient in solving the problems. It will minimize your calculations if you remember those formulas. Along with that, projection from top of the tower concept also we have studied. How we need to solve for this expression for height of the tower, and also time taken or time of travel from point of projection to reach the foot of the tower, right? What is the time taken also we have studied. Under the same application of one certain application, like in case of balloon, if I am going to drop a ball which is rising up, right, what happens for that scenario also we have studied with. Some problems you are having an NCRT based on the same, you have to study with problems related to the foot of the tower or top of the tower. So I hope you got all the points related to the same. I am going to wind up my session for today. We will see the remaining in the next session we are going to have the discussion. Fine. Thank you.